Hello everyone. In this video I would like to explain about small sample test paid t-test. In this video I would like to explain about paid t-test. So before the videos we observed the t-test for single mean, t-test for two means, and now we are going to discuss the paid t-test. So all are small sample test. We discussed that the small sample test means when the sample size it should be less than 30, then we are going to conclude it as a small sample test. So now in the case of paid t-test, we are going to make an experimentation before and after we are going to finding out the values. It means that suppose student is going to write an examination. Before examination, he or she may think that they may get some different marks. After completed to write an examination, their values it will be different. Now the thing is this before and after. So whenever you have the given problem by the examination point of view, we are going to verify whenever we have the data of before and after, and we have the sample size is less than 30, then we are going to conclude it is a small sample test and the test belongs to paid t-test. So now we are going to check that whether there is any significant difference between these two types of cases. It means before and after we are going to conclude that there is no significant difference between two types of the data. So now let us see here, we are going to follow with a 5 steps process. The first step is null hypothesis. So as we discussed earlier, null hypothesis means a statement of no difference is called null hypothesis, and here we are going to take H0. Whatever the given data we are having in the problem, we are going to check that there is no significant difference in the data. So we are going to write the value of H0 is mu1 is equals to mu2. Now we have to follow the second step is an alternative hypothesis. Nothing but the statement against the null hypothesis is an alternative hypothesis. So we are going to define it as H1. So H1, if they didn't ask anything to finding out in the future whether it is going to increase or decrease, the given question is they are asking to finding out whether there is any significant difference in the given data. We are going to finding out H1 is mu1 not equals to mu2. So the test it will be here as a two-tile test. And now let us see, the third step is the level of significance. We have to follow the level of significance. It should be either 5% or 1%. It means that in the given problem, if they didn't ask anything to check there is any significant difference in the given data, we have to follow a 5% level of significance. If they mentioned anything, you have to follow at 1% level of significance. Now let us see here, the fourth step is a test statistic. We are going to finding out the paired t-test. So it will be on the left hand side, we are going to define it as a t. T is equals to d bar by s by root n. T is equals to d bar by s by root n. And here the t follows with n minus 1 degrees of freedom. Here we are having the given observations are n. So it follows n minus 1 degrees of freedom. So here the degrees of freedom means it is nothing but the number of independent variates which make up the statistics to make up our conclusions. So now we are going to finding out the value of d bar is equals to, we can go through the values of x minus y observations. I means I refers to 1 to n, whatever the given observations. It means that we are having the given problems are, given problem we are having n is equals to 10 observations. We are going to write it as the values are from nothing but x1, y1, x2, y2 and so on, xn, yn observations. So in the same way we are going to define it as here, di is equals to either xi minus yi or yi minus xi. So now how to find the value of dr? This is the value of d value we are going to finding out. Now how to find d bar? We know how to finding out differentiation. D bar is equals to summation di by 1, the sum of all the differentiation by the number of observations. So now the thing is we are going to finding out the value of s. S is equals to square root of 1 by n minus 1 summation of di minus d bar whole square. Now we are going to substitute this value of s in the test statistic t, and then we are going to conclude. Now let us see, the fifth step is the conclusion. So in the conclusion, the calculated value of t, if in a case if we got a negative value, we are going through the modulus value of t. So calculated value of t is less than the tabulated value of t, then we are going to conclude or we are going to accept our H0. So it means that there is no significant difference between two types of experimentation of before and after. So if any case if the value of calculated t, in any case, if the value of calculated t is greater than the tabulated value of t, we have to reject h naught. It means that there is some significant difference in the given data. So in this way we are going to conclude, and as well as before that, problems on t-test for single mean and t-test for two mean, we already know that we have an idea about when it is a two-tile test, it follows t alpha by 2, that is of 0.025. Whenever our test, it will be of the alternative hypothesis, it will be on the right tile test or left tile test, we have to follow, it will be of 0.05. It means either 5% or 1% level of significance. So this is the same process, but the thing is we are going to write a different formula and we are making an experimentation of before and after values in the paired t-test. Now let us see the problem on paired t-test. Here the average losses of workers before and after certain program. So when you read out the given problem, you have to identify that the problem is based upon before experimentation and after experimentation. So before and after certain program are given below. Use 5% level of significance to test whether the program is effective. And in the given problem they mentioned here paired sample t-test. In the given question here, if they mentioned or if they did not mention it, we have to follow before and after means, and when the sample size n is less than 30, we have to follow paired sample test only. So now we are having the observation, one is of before and one is of after. So this is the sample size. Now we are having 3, 3, 6 and 7 observations. So our sample size n is equals to 7 in the given problem. Now we are going to finding out the solution of the given values given n is equals to, see here 1, 2, 3, 4, 5, 6, 7. N is equals to 7. N value should be less than 30. So the problem is based upon small sample test, and whenever we are having before and after experimentation, we have to conclude the problem is on paired t-test. So now let us see here, we are going to finding out the first step, null hypothesis. So now let us see here, null hypothesis, it is denoted by h naught. In a given problem, what they are asking in the given question, whether the program is effective. So we have to follow our given given data is correct in the given problem. So we are going to take h naught is mu is equals to with a specified mean mu naught. It means that the program is effective. So we are going to define here the program is effective. So now let us see, our second step is an alternative hypothesis. The alternative hypothesis H1 is denoted by, it means that in the future they didn't ask to finding out whether it is going to increase or decrease after experimentation. So we are checking mu is not equals to mu naught. It means that the program is not effective. So we are going to check here the type of the test in the given problem is a two-tile test. Two-tile test in the given problem. So now let us see here, the third step is the level of significance. The level of significance is clearly mentioned in the given problem is at 5% level of significance, and you can see the fourth step is test statistic. You are going to conclude it is a paired t-test, and we are going to finding out the value of t is equals to d bar by s by root n. D bar by s by root n, and here it follows t with n minus 1 degrees of freedom. And here we are going to finding out the value of d is equals to di is equals to difference of these is xi minus yi, and we are going to finding out d bar is equals to summation di by n, and we are going to finding out the standard deviation, because the given problem we are having only observations, we need to finding out the standard deviation. So we are going to finding out s is equals to square root of 1 by n minus 1 summation of di minus d bar whole square. So this is about our given calculated t value. So now the thing is we are going to finding out the value of the tabular form. So the first tabular form is of before experimentation, and then we are going to finding out after experimentation, and then before and after. So let us assume this as x and let us assume this as y. So the next column we are going to finding it as d is equals to xi minus yi, and the next we are going to finding out d minus d bar, and the next we are going to finding it as d minus d bar whole square. Now let us see the observations before and after experimentation. Before it will be of 40 and it will be of 35, and here 70, 65, and here 45, 42, and here 120, 116, and here 35, 33, and then 55 and 50, and the last observation is we have 77 and 73. Now the thing is we are going to finding out the difference of these observation is di is equals to xi minus yi. 40 minus 35 is 5, and we are going to finding out 70 minus 65 is 5, 45 minus 42 is 3, 120 minus 116 the difference is 4, 35 minus 33 is 2, 55 minus 50 is 5, 77 minus 73 is 4. So now the thing is we are going to finding out first d bar, because we are going to finding out the next column is d minus d bar. So we are going to finding out d bar is equals to summation di by n. So the value of summation di here is equals to 28. So we are going to finding out here the value of summation di is 28. So we are going to finding out 28, and the number of observations here in the given problem is 7. So it will be d bar is equals to 28 by 7 is 4. Now the thing you are going to finding out the next column as d minus d bar. It will be 5 minus 4 is 1, 1 square is 1, again 5 minus 4 is 1, 1 square is 1, 3 minus 4 is minus 1, minus 1 square is 1, 4 minus 4 is 0 square is 0, and here d minus d bar, 2 minus 4 is minus 2, minus 2 square is 4, and again here 5 minus 4 is 1, 1 square, and here 4 minus 4 again 0, so it will be 0. Now the thing is we are going to finding out summation of di minus d bar whole square. It will be 4, and 4 ones it will be 8. So now the thing is we are going to finding out the value of first s value. So s is equals to square root of the value of n is 7 observations here. So 1 by 6 into summation di minus d bar whole square is 8. Then we will get the value of s is equals to 1.154. 154. Now the thing is we are going to substitute this value in the formula of t. T is equals to the value of d bar. D bar is 4. So we are going to finding out 4 by 1.154 divided by root n. Root n is equals to here it will be 7, and it follows the degrees of freedom is 7 minus 1, 6 degrees of freedom. So based on this we are going to finding out the calculated value of t is 9.16. 9.16. Now the thing is we are going to finding out the table value. So the table value we are going to finding out of here n minus 1 df. N minus 1 means 7 minus 1 6 df, and here the problem is of two tile test. If the problem alternative hypothesis, if it will be two tile test, we are going to finding it as alpha by 2 is 0.025. At the left hand side we are going to finding out 7 df, we are going to finding out the value. Now let us see how to check the table value of paired t-test. So we are going to follow as like as t-test for single mean, as like as t-test for two mean, we are going to follow 7 degrees of freedom. It means here in the given problem we are having the sample size is n is 7, so we have to follow 7 minus 1, 6 df. So 6 df at the value of 0.025, because it is a test is a two tile test, so we are going to follow up 2.447. We are going to follow the table value is 2.447. Now let us see here the table calculated value is 9.16 and table value is 2.447. So we are going to conclude here now 9.16 is greater than 2.447. So the thing is we are going to reject H0. So reject H0 means what we are taking here the null hypothesis. The null hypothesis is the program is effective. Now the thing is we are going to conclude by using calculated value and by using the tabular value. We are going to conclude that rejecting H0, it means that the program is not effective. So there is no improvement by using the program. So in this way we are going to conclude the paired t-test. Thank you.